Is the video for homework 1 assignment for CPSC 5260, Introduction to Parallel Algorithms. So this homework 1 assignment is just a serial C program to generate a small-ish array of random values and show that the standard deviation is lowered as the array is smoothed out. So first up, I'll walk through the code just sort of line by line and bit by bit, and then I'll compile it and run it and show the output. So first up, to compile, here we have this command. This is what we need to run into the terminal. We need to use the WALL flag to see all the warnings that the compiler throws. So here we just have our includes. We need to include stdio and stdlib. This is standard. We include time.h as well, because that's how we get the seed for a random number generator. And lastly, we need to include math.h so we can calculate the standard deviation. So this block here just defines all the functions and the prototypes for all the functions. I'm not going to get too into that. So here we have our first function definition. So this function just makes the array of random numbers. It takes in the array, the size of the array, and the scale, which should be from a factor of 0 to 1. So first up, we have a check here to make sure that the array actually exists. And if it doesn't, then it exits the functions. But if the array exists, we go into this for loop where from I to the entire size of the array, we just assign a random value to the ith index of the array. Next up, we have a function to calculate the sum of all of the elements of the array, and this just takes in the array and the size as well. So first we initialize this variable s that will be our sum that we return. Again, we have the same check to make sure that the array actually exists. Next up, here we just have the simple summing for loop of it, and we return that double s as our sum. Next up, this function calculates the standard deviation. Once again, it just takes in the array and the size as arguments. And we also have that check to make sure the array exists. If it doesn't, it exits. First up, we define this double m to calculate the mean of all of the array values, and this is using the formula for standard deviation. And next we have this double var, which will be the actual value of the standard deviation. And this for loop here just calculates the standard deviation across like the entire array. And lastly, we return the standard deviation. This last function smooths the array. It takes in as arguments the array itself, the size of the array, and also this w, which is the weight factor for smoothing. We have the same check to make sure the array exists, but we additionally have just a check to make sure that the array is like adequately large, because if it's a very tiny array, there's really no need to do smoothing, and there's not much that will be done. So there's a check there. These next two checks check the magnitude of the weight. So the weight should be between 0 and 1. So this line here, just, if it's less than 0, then it makes it 0. And if it's greater than 1, then it makes it 1. Just to sort of put it more firmly enforce a bound on W. Next up, this line, we create a temporary array to do the smoothing. We allocate the memory for a temporary array. And next up, we actually assign values to the array itself. We copy the array values into the temp array and put that into the for loop here, which takes in the old values of the array and then updates it to the temp array, which is the new array. It updates it to this according to this formula here, which was given in the homework assignment, and this just smooths the indices of the arrays with their neighbors by this weight factor. So once we have that temp array of the new values, we do a for loop and just assign array equals the temp array values, and then that's all we have to do for the smoothing step. And lastly, now that we're done with all of that, we need to free the memory for the temporary array, so that way things don't get slowed down if we run this multiple times. So that's all the functions defined. Now we go into the main. First up, we just define the size for the array. Right now it's 20, just for small-ish values, but this can be any like smaller or larger values. We have this scale factor, which is used in the random number generation, and this just ensures that the random numbers generated are between 0 and 1. But if you wanted to, you could set the scale factor to something else, maybe like 10 or 50, in order to make the random numbers generate between like that range. Next up, we have the weight factor for smoothing. This should also be between 0 and 1. Right now I have it set to 0.6. And lastly, we have the iterations, which is the number of times that the array will be smoothed. And right now this is set to 8, but again, this can be set to less or set to more if you want to see more or less smoothing occurred. Here we make the seed for the random number generator, and that's why we need time in the includes, because we use the time to make the random number. Here we go, and then here we print that out to the terminal just so we can see our seed each time. Now we allocate the memory for the array itself, according to the size that we have set up here. We allocate memory for the array. And if for some reason allocation fails, it just prints it to the console and exits the script. Next up, here we call the random array function to actually assign values into that array that was that we had the memory allocated for. So the random array will go through each index in the array and assign it a random value between 0 and 1. Here we print off the values of the initial array just so we can see it in the terminal, and then we also calculate the standard deviation of the initial array and print that to the terminal as well. So this is the last part, the smoothing of the array. So we have a for loop going through 1 through the however many iterations defined are up here. So right now it's set to 8, so this for loop will go through 1 through 8 of smoothing the array. It'll call the smooth function, pass in the array, the size, and the weight, and then it'll calculate the standard deviation of the new smoothed array. And lastly, it'll print out the iteration count and the standard deviation. So once that's done, everything is finished. We don't need to do anything else. So lastly, we just free the memory from the array, so it doesn't get bogged down later on and we don't have tons and tons of memory being hogged by this program. So once that's done, we exit the script. So with all that, I will go up to the top, and here's the command for compiling. I will compile it and run it, and I'll show the output. So let me go over to the terminal. So right now, we can see we don't have anything. All we have is the just C file and a text file from the previous output. So we paste this command into the terminal and compile it. We see that we don't get any warnings, and now we have a program that we can execute. That is the script. So let's run that, and then we can see the output. So here we see, yes, this is the random seed that we have generated. And here's the values of the initial array, each one, and we can see the standard deviation of the initial array as well. And this last chunk of text down here is the smoothing iteration. So we can see after each iteration, the standard deviation gets lower and lower. And that's all we have to do for the assignment.